Okay, here we are back at VCAA 2021 Maths Methods Exam 2, Section B, question 4 this time. So, looks like a probability question here. So, teacher coaches the table tennis team. They've got a ball machine to practice, speeds measured in metres per second, normally distributed. Okay, there we go. Random variable W. Teacher sets the ball machine mean speed of 10. Standard deviation of 0.8. All right, so let's see how we go here. So the probability that our random variable is greater or equal to 11, so which the random variable is the speed of the machine. And so we need to get our calculators out and use that. So here we go. For the Casio, we've got interactive, distributions, continuous, normal, CDF, and our lower we wanted it to be 11. Our upper, we just need to make a big number. Our standard deviation was 0.8, I believe, yes, 0.8, and our mean was 10. And so then we go and we've got 0.15 564 and some more stuff, but we're asked for 3 decimal places here, so 0.105, but notice the next one after it's a 6, so make sure you round correctly. All right, so 1.106. So find the value K in metres per second, which 80% of the ball speeds are below. So what are we doing? Probability that the ball speed is less than K, which we want speed below that, and how much we want 80%, which is 0.8. All right, and so then we need to go to our calculator again. And this time, when we go there, we want the inverse, and we want the inverse normal. And we're wanting the less than end, the small end, so the less than small end is on the left, so the tail setting is correct. We want 0.8 to be our probability, 80% less than that. Our population standard deviation is 0.8 and population mean was 10, yes, just checking that. And so then we've got 10.6732 and some other stuff. So K equals 10.6732 and some other stuff. In this case, we want 1 decimal place, so that means that K would be 10.67, so we need to round up 10.7 again. As I said, make sure you round correctly. If you don't round correctly, you get nothing for those two. All right. Teacher adjusts the height setting for the ball machine. The ball shoots high above the table. Unfortunately, with the new height setting, 88%, balls do not land on the table. Let P be the random variable sample proportion of balls that do not in random samples of 25 balls, so n equals 25. All right, so what are we looking for? We're looking for the expected value of our proportion. All right, which is P, to be, and it's 8% of the balls. So 8% of our balls, 0.08, come off the table. Now, 0.08 as a fraction is 2 on 25, if we need that. All right, so this, where did I get this from? I got this from the formula sheet. Now, they have asked for exact values, so again, I don't know, it's debatable. Is 0.08 okay, or do we have to know 2 on 25? All right, so this is on the formula sheet. So make sure you look at the formula sheet. And here's one here. So here, this is what I'm using for my formula sheet. There it is. Proportions, mean of the proportion, and a standard deviation. So I'm using these, that one there and that one there. All right, and so the other one, the standard deviation one, for our proportion, is that formula, which is the square root one, and it's the 0.08, 1 minus the 0.08 over our sample size of 25, and then you, again, we want exact answers. Make sure you have your calculator set in exact, and what you come up is square root 46 on 125 for that. All right, so the reason I say it's got exact answers, unlike the previous two, there's no, and this next one, there's no mention here of correct to any decimal places. So that's why I've given those in that form. All right, so use the binomial distribution to find the probability that the proportion is greater than 0.1. So we want the probability that our proportion is greater than 0.1. All right, so what does that mean? All right, proportion. Proportion is the number that we have over the 25. We want that to be greater than 0.1, which then means the probability that x, if I times both sides here by 25, we want probability that x is greater than 2.5. Now, this is binomial distribution here, it says. So pick up on that, different to what we've been doing previously. And so binomial, we can't have fraction outcomes, because binomial's either what you want or not. So you either get it or you don't. You don't get half, there's no halfways or whatever. So if we want greater than 2.5, we're actually wanting greater than or equal to 3. And so we go to our calculator, to our binomial CDF on our calculator, and we put in the information that we need to put in. I'm going to do that one. You saw me do some stuff previously, so it's in the same area as that. And to 3 decimal places is 0.323. All right. Then we move to the next part, part E. And for part E, we're moving on to still probability, but something else. Teacher can also adjust the spin setting. And so spin, measured in revolutions per second, is a continuous random variable with this probability density function. Now, it doesn't ask you to do a sketch, but for this question, a sketch can be quite handy, because if I've got here x, and x is my spin, all right, and spin is between 0 and 20, it's that function. And then from 20 to 50, it's this other function. Whoops. All right, now it'd be handy for me to know what that high point there. Now that high point there relates to when x is 20, so when x is 20, you got 20 on 50, which comes out to not 20 on 50, 20 on 500, which comes out to 1 on 25. So this up here is 1 on 25. All right. So the maximum possible spin applied to the ball in revolutions per second. All right, we just simply get that from our function here. And when we look at that, the maximum is 50. So the max spin is equal to 50 revolutions per second. All right, now it asks us to find the median spin. All right, so the median spin. So the median is like the middle, up to 50%. Now, if we, for example, find out this first part up here, because the median is like to 50% or 0.5. But if we work out this area in here, and we can work it out in a couple of different ways. One of them is the integral, 0 to 20, x on 500 dx. And if you work that out, you get 2/5, which is 0.4. So that's not where the median is. So the median's got to be somewhere here in this top half, because we only got 0.4 up to 20, and so we need another 0.1 here. So from 20 to our median, and this time we're now using the 50 minus x on 750 dx, and that's got to be 0.1. All right, because up to there, that's 0.4, and so we need another 0.1 in there to take us up to halfway. All right, then we get our calculator to solve that for us. And so to 1 decimal place, you get 22.6. All right. All right, so just getting your calculator to solve this particular function. All right, then we now move. Find the standard deviation of the spin correct to 1 decimal place. All right, so to do that, we need continuous. So to do that, we need this. So we want the standard deviation, which is the square root of the variance, and we need the mean. All right, so we need to use both of those. So first of all, we need the mean. And so the mean, from our formula sheet, our mean would be, there's 2 parts now. Of course, we've got to split this into 2 parts. So it's not just 0 to 50, because we've got 2 parts to this. We've got to go 0 to 20 and then 20 to 50. And of course, this is all calculator stuff. So it's 0 to 20 of x times the x on 500 dx, plus then the 20 to 50 of x times 50 minus x on 750 dx. And when you get to that, you get 23.33 and then more, which is 70 on 3. Now I know it says to 1 decimal place, but I'm just going to use the 70 on 3 to begin with, and we'll, at the end is when I'm going to go to 1 decimal place. All right, so then my variance, and again, this is for the from my, is from the formula sheet, again, 2 parts, 0 to 20, x minus the mean, which is 70 on 3, all squared on that times my function, dx, plus then the other half, the 20 to 50, and we've got x minus the mean again, squared times the function, which for this part is the 50 minus x on 750, dx. And when you do that, and again I'm going to use the fraction bit, you get 950 on 9. All right, so then the standard deviation, of course, is the square root of that stuff. So I could have actually gone straight to my final answer there, because we're in our final answer asked to do correct to 1 decimal place, and so that's 10.274, which of course correct to 1 decimal place is 10.3, so make sure you round it off correctly. All right, so a little bit tricky, a bit complicated with some stuff in that. All right, because they're chopping around a bit in this particular question, so we need to have our wits about us. All right, then the last part. Teacher adjusts the spin setting, so the median spin now is 30. This is transformed in this way here. All right, now the median spin now is 30, so that's in the top half, all right, of that thing that we looked at before, right, up here. I drew that graph, said it again. So 30 is up here, so we've changed our median from the 22 to now to 30 by doing that transformation. All right, so what do we got? We've got g of x then is AF of x on b. Now we're in the top half, and so in the top half we've then got a times, and our function is 50 minus x, so it's now 50 minus x on b all over 750. Now, our original, so now we've got between 20, because we've changed this now to x on b, so 20x on b to 50. So now our domain then changes, so this is for, if we times everything by b, for 20b being less than or equal to x being less than or equal to 50b. All right, so the median is in this domain. Now there's a couple of different things that we can have a look at here. So let's redraw that. So, whoops, get rid of this. Let's get rid of that. So redrawing our function to what we had before. So what we had before goes up there like that and then down here like that. And so now this point where it changes over is 20b. This point here is 50b, and our median is here at 30. All right, in the top half. Now this, we've also had a dilation here of 1/25, and that's 8. So that's what we now have. And so this point here has the coordinates of 30 and g of 30. All right, which is our height, which is this one here. All right, so why have I done that? Because what I can do is I can come up with a couple of different equations, because I know this total area has got to equal 1. So total area has got to equal 1, and I'm just going to use the area of a triangle formula. I'm not going to do integrals here. Area of a triangle formula, half for the base times the height, and that equals 1. All right, so the area under, so the total area is equal to 1. And so that total area is the half times the base, which is 50b, times the height, which is 1 on 25a, and that equals 1. All right, so when you figure that stuff out, what you find out here is that AB is equal to 1. So there we've got an equation. Now then, from the median to the top, if you like, what we know about that area is equal to 0.5. And when we look at that, you see that that's a triangle as well. And half the base is 50b minus 30, and then we've got this height, which I will put into the function, and we'll find that out in a minute. So we've got a half of your base, which it said was 50b minus 30, times the height, and the height is when x is 30, and remember this is now our function, so that's a 50 minus 30 on b on 750, and if you get your calculator, or you neaten that up, you actually don't need to get your calculator to neaten that up, that comes out to be a 50b minus 30, 50 minus 30 on b, and that's all over 2 times 750, which is 1,500. So we've now got 2 equations, and we can solve those 2 equations simultaneously using a calculator. And when you do that, you get a couple of, you actually get 2 answers. You get one answer which says that A is 2.560 and that B is equal to 0.388. And the other one, it says that A is 0.754 and B is 1.327. Now, if you, with these first 2, if you could find out what 50b is, which is 50 times 0.388, that comes out to 19.4. So what it's saying is that this endpoint's 19.4, but the endpoint can't be 19.4 because 19.4 is less than 30. And we've been told up the top there that our median's 30. So our endpoint's got to be bigger than 30. So that can't be the solution. So A, and 2 decimal places, has got to be 0.75, and B to 2 decimal places, it's got to be 1.33. And again, make sure you round off correctly. All right, so that's how I have done those particular questions. There might be other ways of doing. You may be able to define functions and things and do it that way. Hopefully a calculator will be able to handle that. All right, as always, make sure you speak to your teacher, get their opinion, and also look at the examiner's reports.